Hi everyone, my name is Hannah Duzz, and today I am going to be talking to you about my oceanography homework, which is on the geologic history of Iceland. A little bit about the geology of Iceland. Iceland is actually a country. Most people tend to believe it's a region or a city, but it's actually a country and it is located in Northern Europe. Iceland is a isolated country, kind of like a circle in between two other areas, all by itself, and it is on top of the Mid-Atlantic Ridge. Iceland sits on top of the Mid-Atlantic Ridge, and on top of the Mid-Atlantic Ridge, it acts as kind of like, in my mind, glue for the North American and Eurasian plates where they meet together. So you have two pieces like this, and then the Atlantic Ridge on top of it. Iceland is known for volcanic and geological activity because of the plates constantly moving underneath the ridge. So everything's happening down here, and then it's creating things to happen on top like so. About Iceland's general mineral composition. Basically, it's basaltic because there is a constant supply of magma from the separation of the plates flowing upward, forming volcanoes. There has been over 20 types of igneous rocks found in Iceland, but the most commonly found is olivine basaltic. There are other kinds of rocks in Iceland, such as zeolites, isandlites, rhyolite, and palagonite. Sorry if I mispronounced those. Iceland's creation history and major geological change. Iceland first started its formation around 70 million years ago, so it has been around for quite some time, actually before humans were around. It started forming when the Mid-Atlantic Ridge was giving away, allowing plumes to form and appear. There is also a magma pocket called the Iceland plume, which is what Iceland is on top of. It is said that millions of years ago, about 70 to be exact, there were several underwater eruptions from the Iceland plume that occurred, and this led to the creation of Iceland. The island still continues to grow and develop today due to ongoing underwater eruptions. So, to recap that, Iceland was created by these two pieces separating, which caused magma to flow up, which created the island because it formed above sea level. So now the walls continue to move at a pace, and more flows up, creating the island to grow bigger. Iceland is home to over 200 volcanoes because of the constant supply of magma, allowing more volcanoes to form and continue to be active. In 2010, the volcano named, I can't pronounce that, erupted, causing a huge cloud of ash everywhere, similar to, like, I guess you could say a bomb eruption where the cloud kind of goes like a mushroom and then grows everywhere and continues to spread throughout the air. With this volcano eruption happening, the cloud of smoke stayed in the sky for a while, which made all air travel not possible, which led to the cancellation of 1,700 flights. Geologic mechanisms that led to the creation of Iceland. So, let's see if we can move this over. Perfect, just while we talk. Iceland sits on top of the Mid-Atlantic Ridge again, under the North Atlantic Ocean, where Eurasian and North American plates in the Earth's surface move. So, you can see kind of a good view of this in this first picture right here. You see Iceland sitting again on top of the ridge, which divides the North American plate and the Eurasian plate. You can see the spreading center right here, where the oceanic crust is broken through by rising magma, magma, which again created the development of the ice of Iceland. In the second picture, you see a diagram about hotspots, which are sort of like the leading cause to the formation of Iceland. You can see how at the bottom of the diagram, heat is transferring, causing the plates to drive apart, forcing magma up through. And after the plates separate, the magma can flow through in a seam, creating volcanoes or volcanic vents. But when it rises to the surface of the ocean, where you can see it, it creates something called an island, which we refer to in this example as Iceland. In the third picture or diagram, you see the island's Rift Valley, which is right here, this dotted line, also keyed at the bottom. And the valley acts as a boundary between the Eurasian plate and the North American plate, which is where all the activity is that is causing future developments throughout the island. Next, let me move myself back over. We have Iceland's current status. Iceland is constantly changing and developing because it is on top of the Mid-Atlantic Ridge, which is expanding currently at 2 centimeters per year. So it is still rapidly moving and constantly developing more features and growing bigger. The eastern part of the island moves towards the east, and the western part of the island moves towards the west, maintaining the separation, allowing more formation to occur. As the Eurasian plate and the North American plate drift apart, it causes more magma to rise, forcing the plates further and further and further. This happens at a slow rate, so it's not necessarily something you could see with your eye, but it's still happening. And tectonic plates are the active force leading to the formation of Iceland. Iceland is currently dealing with issues of climate change as ice is melting more rapidly, which is leading to an increase in volcanic activity. So in Iceland, they are dealing with lots of climate change, which makes the volcanoes act kind of sporadically and rapidly, which is not good, obviously, for the environment in Iceland. So this is not really something that we want to be happening in Iceland, which is why we kind of need to get, or anywhere as a matter of fact, which is why we need to kind of get a grip on the climate change, because this could be dangerous or fatal for people living in Iceland or other places where this may be happening. And finally, we're going to talk about Iceland's future. Iceland is one of the places in the world that, again, is being affected by climate change, with glaciers melting and volcanoes erupting. Iceland's oceans are rising at an alarming rate. There is also research that shows predictions for more glacier melting and heightened volcanic activity. So again, as the plates are continuing to separate and climate change is getting worse and things are getting warmer, glaciers are melting and volcanoes are erupting or forming more rapidly because more things are happening, which are causing this to happen. And extreme weather can have a negative impact on Iceland as these geological features occur, but it also affects tourism because, well, some people might be scared of the unstable environment, or some people might not find it as interesting to see climate change affecting Iceland negatively versus affecting it positively, where climate change wasn't as bad before. And yeah, that's pretty much a summary of my presentation. Thank you for watching.